Hi, in this video we'll do simple linear regression analysis using Microsoft Power BI and Python and Excel. Linear regression is a statistical technique that shows how two variables are related and it can be used to predict future value. As you can see on the right, we have a scatter chart where we have independent variable on the x-axis and dependent variable on the y-axis. And you can see that it's a perfect fit. There is a regression line also. The values are almost matching. In the sense there is a linear relationship between these variables. If we swap out the total distance and change it to total calories, and here you can see the values, the data points are scattered, right? Now if you add a trend line here, and like I said, the data points are scattered widely around the regression line. And linear regression is useful in calculating a straight line that specifies a mathematical relationship between two variables, right? It can be expressed mathematically as y equal to mx plus b, and where y is the predicted value. In our case, it is our total distance, and m is the slope. It indicates how much y changes for every unit change in x, and x is the independent variable. In our case, it is total steps, right? So the intercept is where the line crosses the y-axis, the value of y when x is 0. Let us try to swap out to total distance. So that is what we want to predict, and independent variable is x. Now that we have understood, we can also look at the regression line. This is the regression line, and it is again expressed mathematically as y equal to mx plus b. And there is a mathematical relationship. So it will define a linear function between x and y variables that best showcases the relationship between the two. So now that we have understood the basics, let us try to look at the documentation, Power BI. We can use two functions in Power BI. There are LINEST and LINESTX. It's the iterator function. Both functions expect certain parameters. As you can see, LINEST expects column x, column y, and column x, and both of them return a table, a single row table with a lot of statistics. This is the LINESTX function, which is an iterator function. It expects a table and expression y and expression x. So we have more control in using LINESTX function, and it uses least squares method. And these are the 10 various statistics are the output in the table when you use the LINESTX function. So these are the various things: the slope, the intercept, and also a coefficient of determination, a standard error, and as such. There are very useful statistics which are given. Again, this is a return value is a single line table. So let us try to use a DAX query view and try to understand a little bit more about LINESTS function. So let us try to create a variable linreg equal to LINESTX. As you can see, a table is expected as a first parameter and expression y and expression x. So let us try to use all selected around our calendar table. That is the first table parameter. And for the second expression y, we have already decided that the total distance will be the y. And for, in our case, total steps is the expression x1. And close the parenthesis and the return. If you return this, we already know that this returns a table. Run it, and here you have all the statistics, 10 of them, slope, intercept, and as such. And again, we can review. We are interested in 3 of them: slope, the intercept, and coefficient of determination. It is called as R square. It is a statistical measure that tells you how well a model fits the data. In our case, it's 1. So that shows that it is a strong correlation between the data points and the regression line. So these are the 3 things which you are interested. And once we understand that, let us try to go and create another measure. So we will call the measure as predicted distance. So let us try to go back to DAX query view, and let us try to copy that. So let us try to copy this part, and let us try to paste that in the and store it in variable table. Now, as we've already seen in the table, the output, there are columns. We are interested in slope one column. Let us use select columns function, grab that slope value, and similarly for intercept, we'll also try to grab that intercept value. We know that column, right? So we already know the expression line equation, y equal to mx plus b, and we'll create a variable y and slope times total steps plus intercept. And this will give you y. So this is a perfect way, and we have created a measure, which will give you that predicted distance. And next is we want to see how far the predicted values are from the actual values. That is called as residual. So before we move forward, let us try to understand a couple of terms. Standard deviation, it's a measure of precision. So it tells you how spread out the data is around the mean. And here are the listed steps to calculate the standard deviation. There is a default function in our DAX. We can use that. And also the second one is we want to understand what is root mean square error. It is a measure of accuracy, and it measures how spread out the residuals are, the average difference between the predicted and actual values. So this will tell you basically in regression analysis, it will help us to understand how accurate our model is. A small value indicates estimated mean is close to the true mean. So we wanted the lower values, right? So this is the formula, and it's pretty easy. The residuals squared, sum, and take the average and square root. So we will do step by step. We will try to create another measure which will give us RMSE value. So this is the final measure. To save time, I've already written the code, but we'll go step by step and try to understand the logic. And we have created a variable table, and I've used add column. So let us try to copy that. Let us try to go to our DAX query view and see how it works. So let us create another query, evaluate selected columns. And selected columns returns a table with selected columns from the table and also new columns specified by the DAX expression, right? So I just wanted to demonstrate that. If we name it as predicted distance and pass the predicted distance measure which we have created and run it, and you can see, and a single column is in the results pane. So once you wrap everything around select columns and add those columns whatever you want and pass the expressions, the measures as expressions, you get 4 columns. So this is exactly what we wanted. We wanted date and total steps, total distance, and predicted distance also. So this is the first variable we've already seen. And the result, we already know the formula for RMSE. So it's little bit, it looks complicated, but we'll do step by step so that we'll understand what is going on. First, we want to calculate the residual, right? So that is, we want to see what is the, how far the predicted values from the total distance. And we will try to square them around using the power function. Once we do that, we have we can wrap everything around average x. Average x expects a table as the first parameter, and the expression is already there. Once we do everything and wrap it around square root function, we'll get our RMSE. This is the report page, and we have a slicer on the left, month, year, which is coming from the calendar table. And the second visual is a table visual. So I just wanted to see how our predicted values are compared to the original. So there is a date, total steps, actual distance, and predicted distance, and also what is the residual, the difference between the predicted value and actual value. And on the right, you see a scatter plot where the data values and x-axis is total steps or independent variable, and x-axis is the predicted variable. And I've already added tooltips, residual as a tooltip. So if you hover over any data point, you have an idea what is the residual and what is the predicted value and as such. So you can use the slicer on the left and the values will change. And I've used a card visual and passed the RMSE. So the beauty is that we can use the slicer, and every time we select a particular month, the values also keep changing. And the table values and also the scatter plot also will change. This is the standard functionality, so all the visuals are interactive. I think this is pretty cool, and we have renamed the x-axis and y values also. That's cool. So we just wanted to use Python quickly and try to compare the output of our Power BI values with the Python. So I'm using pandas, and you can pause the video and look at the code. It's a pretty simple code. I've loaded the dataset. I'm looking at the top 5, and we know x and y values. We have added that, and I'm using sklearn. So test is we're using train test split, and initiating the model. And if you print the model score, it's almost perfect. In real world cases, it's not the case, but we have your intercept and also the slope. So we can just quickly compare these values with the Power BI values, right? So we just wanted to make sure as a sanity check, we have those values, right? So you can see the slope. And again, in our Power BI, the slope is rounded off to the nearest zero. So it's that value, and intercept is also matching, almost the similar. The slight variation is because we have split the data in Python. So we have used the split test and train using the function. So we have those changes, and I'm just trying to visualize the predicted versus actual. So you have those values, and also we have your root mean square error. It's perfectly matching with our Power BI values, right? So this is one way of kind of cross-verifying if we have done correctly in Power BI. And as you can see, the RMSE is also almost similar. And quickly, we can also use any kind of spreadsheet application like Excel or LibreOffice and select the X and Y values and right-click, create a chart, make it a scatter chart. And if you right-click on any of the data point, you can insert a trend line and show the equation and click OK, and you have the equation up top. So that is the equation we have, and we can always create a new column in this Excel sheet itself, which will calculate the predicted distance like shown here using the function. And I've created a new column there. And once we created that, we can always compare that with our Power BI output. So I think both of them should be similar. And we can try to extend the concept now and create a dynamic prediction vision in a report page. So what we can do is we can go to modeling and create a new parameter and name it as predict distance parameter. And the range will be 1,000 to 50,000. So the reason why we are doing it, right, we want to not only look at the values within the max value what we have in our data, we can also look at the future. So I am just trying to create a new measure. So we will copy the same predicted distance measure and create a new measure. We have to tweak this code. Instead of the hard-coded total steps, we can add that predicted distance parameter value so that it will be dynamic. And whenever the slicer which we have on the report page, once we use the slider and change the values, there is a card visual on the bottom. So you can see if you change the values there, use the slider, and those values are also changing. The range of values are 1,000 to 50,000. So not only the maximum value what we have at 28K, so we can see beyond 28K also. That is the whole purpose, right? We wanted to predict the future value also. Suppose we want to verify whether approximately our dynamic prediction is correct or not. 10.94 for 22,450. You can see here approximately that is also matching up, right? 24 to 50, it is matching up. And like I said, the maximum value of X is about 28K. So we have created this numerics parameter in such a way that it will have a range of values beyond the max value of 28K. You can use the slicer and make sure that that is working perfectly. And in a short time, we have created report pages. We understood what is LINESTX function, and we have created a report page, and we have table and slicer and scatter matrix. And also we have kind of extended the concept and made it into a dynamic prediction also. So I hope this video will help you in understanding linear regression. Thanks for watching, and see you in the next video.